Hello everyone. Today we'll be discussing sorting algorithms, specifically bucket sort. Sorting algorithms are used to arrange data in a specific order, and bucket sort is a useful algorithm for when the input is drawn from a uniform distribution. So first off, let's look at the table of contents. You have the introduction, a bit of implementation. We'll go over code and also discuss the time complexity of bucket sort, pros and cons, and also conclusion. So first off, what is bucket sort? So bucket sort is a comparison sort algorithm that works by dividing an array into a set of buckets. Each bucket is then sorted individually, either using another sorting algorithm or recursively using the bucket sort algorithm. The elements are then combined back into the original array in order. So how bucket sort works? So the first step in bucket sort is to set up the buckets with each bucket representing a range of values. Each element is then placed in its corresponding bucket based on its value. The elements in each bucket are then sorted, either recursively using the bucket sort algorithm or using another sorting algorithm. Finally, the elements are concatenated to get the sorted array. So now let's see how this works. So here's a bit of an image to help you understand the implementation better. So on the image on the left here, we have an array with numbers ranging from 0.0 to 1 and that are not uniformly distributed across the range. So you have 0.78 here, you have 0.17 here, 0.39 here. So a simpler way to sort is to apply comparison based on sorting algorithm, lower bound for comparison based on sorting algorithm, merge sort, heap sort, quick sort is omega, and they cannot do better than n log n in terms of time. So this is what our algorithm would look like. We'll create a bucket sort array, create n empty buckets or lists, do the following for every array element, array I all the way down to A, insert array I into bucket, and star array I, sort individual buckets using insertion sort, concatenate all the sorted buckets. So this is what it'll look like after we have created our bucket. So for example, for 0.78, we don't have anything over here. But once we move on to 1, with numbers ranging from 0.0 to 1.0. For 0.1, we have 0.12 and 0.17 in buckets over here, and then we have 0.21, 23, 26 in buckets over here for array index 3 or 0, 1, 2, and then all the way down to 0.94, which goes to array index 10 over here. So our buckets are created, and we have them in order, which are sorted. Okay, next up, let's look at a bit of code here. So this is how the code works. First, you need to create a C++ program to sort an array using bucket sort. You make sure you have all your includes. And then let's look at a function to sort array of size n using bucket sort. So we create our function over here, then create empty n buckets, so vector float bn, put array elements into different buckets. So for int I lower than n number of elements, we increment it, and then for this, we get an array index in bucket, and then we push it back. Sort individual buckets. So this is how we sort our individual buckets. So starting off at 0, once again, for I lower than n, I plus plus, we sort it using the sort function, and then all the way down, starting from I all the way down to the end, and then concatenate all the buckets, starting at 0 once again. For I, so we need to create a nested for loop here. So we have two for loops to increment or run through both of them to create an index that is to increment the index on both parameters I and j. So after that, we kind of run it through our main function. This will what our array or our float array would look like. Then we declare the size using that, and then we see out a sorted array. So as you can see, here's the output. This is what we input into our function. You can see the numbers aren't really sorted, and then our sorted output array kind of looks like that. So over here, we start off with 0.897 all the way down to 0.34, which is not in order. And then over here, our sorted array is 0.1234 and then 0.34 all the way down to 0.897. So after that, let's talk about time complexity of bucket sort. So in terms of time complexity, our best case for uniformly distributed arrays would be O n plus k, given that the time complexity depends on the sorting algorithm, and we are also assuming that the complexity is O n log of n. So here, n is the number of elements, k is the number of buckets, so O n plus k. Then the average case of O n plus k, average case is also O n plus k when the elements are uniformly distributed across buckets. But then we have worst case, so all the elements are placed in a single bucket, another algorithm is needed. This is when we have all the elements placed in a bucket, but we need to implement another algorithm. The time complexity of the bucket sort would be O n plus 2. However, this is a rare occurrence, and the worst case time complexity can be avoided by choosing the number of buckets carefully. Okay, now let's talk about a few advantages and disadvantages. So, bucket sort is efficient for large data sets and has a linear time complexity of O n plus k, where k is the number of buckets. It's an efficient algorithm for sorting elements that are uniformly distributed across the range, and it is also relatively simple to implement. The disadvantages, however, are that the algorithm can be inefficient for datasets with skewed distribution of values. It can be less efficient than other sorting algorithms with datasets with small number of elements or large range of values, and the number of buckets must be chosen carefully to avoid inefficiency. As we looked in the previous slide, that time complexity does depend on the number of buckets, so we need to make sure we're choosing it carefully. And lastly, here are a few applications. So it could be used in a database or a data file system to arrange data in a certain way or a certain manner or sort it out, which is very helpful using buckets. It's useful in parallel computing, where data can be distributed across multiple processors. It can be used in construction of histograms and also frequency tables. In conclusion, bucket sort is an efficient sorting algorithm for large data sets with uniform distribution. It can be used in a variety of applications in computer science and other fields. Care must be taken when choosing the number of buckets and considering the distribution of values in the dataset. As we mentioned, time is an important factor here. Right, thank you all for listening. If you have any questions, please email me at my email over here. Thank you.